Okay, this is number 13C. It's an absolute value inequality. And so I'm going to just do sign analysis for this one. So first we solve the related equation. And in this case, it's absolute value of 3x minus 2 equals 10. And this is to get boundary points. Okay, now we can split that into two. So it's 3x minus 2 equals 10, or it's 3x minus 2 is negative 10. And so now we'll solve this. So 3x equals 12, so x is 4, or 3x equals negative 8, so x is negative 8 thirds. Okay, and now those are my boundary points on my number line. So here's my number line. Negative 8 thirds goes over here. 4 goes over here. And then we're going to test. So let's test something definitely less than negative 8 thirds, like negative 10. Let's test x equals 0. And let's test like x equals 10. So if I plug in negative 10 over here, I get absolute value. Remember, you're always plugging in the original. So it's 3 times negative 10 minus 2. And checking, is that greater than 10? So that's going to be negative 30 minus 2 is negative 32 in absolute values, which is positive 32, which is definitely greater than 10. This is true. Okay, if we test 0, we get 3 times 0 minus 2 in the absolute values. And is that bigger than 10? Well, this is negative 2, which is just 2 in absolute values. So that's false. And then over here, if we test 10, it's 3 times 10 minus 2 in absolute values. Is that bigger than or equal to 10? That's going to be 28, which is bigger than 10. So that's true. So now I know it's this part and this part. And the other thing I know is that both of them came out of something that had the equal sign attached to it. So both these dots are included. Okay, now if you had to write out this algebraically, this is the graphical solution. And if you needed the algebraic version, then you write the inequalities. So this is going to be x is smaller than negative 8 thirds, or x is bigger than or equal to 4. Sorry, this should be less than or equal to over here because the dot was included. And there we go. All right, I hope that helps.